Hello, everybody! Back again to another episode of our live show. And today, the topic we have is actually eco informatics. And when I said this sentence that we do a show on eco informatics, my guest totally fell into laughter because apparently he never heard it before. And my guest actually is Chris, and I think you know him best from his work on Hazelcast, but actually he's doing a really interesting project right now, which is Cleverbit, and I hope we can see a bit of the Cleverbit. So here is Christoph. Hello, Christoph. How are you?
Hey, hi Marcus. Good to be here.
Yeah,
But no, seriously, I actually never heard this term before.
yeah,
As I said in our little chat before, what we normally call it is data-driven farming, digital farming. Even though it's actually about animal farming, like animal husbandry, not like agri farming. But nobody knows what you're talking about when you say it's animal husbandry.
yeah. And anyways, because you did such a great project with Cleverbit, this will turn into the generic term actually. So when competitors will come up, everybody will say, "Do you do Cleverbit?" They won't say digital farming. They will say Cleverbit.
You know that it's a complicated thing to have the company or product name as like a category kind of
Yeah,
thing, right?
yeah,
In Germany we have Tempo, which
yeah,
is a tissue, which in the US is just forgot the term, but
yeah,
it's always a little bit of a complicated thing if you really want that or not. Like there was a strong discussion from Google in the sense of how you are okay to use the word Google. I mean, we have it
yeah,
in our dictionary now
yeah,
to Google something.
yeah, yeah. And what does the competitors think about that when you say, "Let me Google that on Yahoo"? This is some kind of weird.
No, so I'm not sure how it is for the English dictionary, but for the German dictionary, to Google something
Yeah.
specifically mean to search on Google. That is
Really?
exactly what
Oh,
I'm. That is exactly what I meant. Where
okay.
Google was like, you have to be precise when you want to put this
Hmm.
in the dictionary.
Actually, I know a lot of people who say, "Let me Google that" when they use a totally different platform, like they go on Twitter and search there. So they are Googling on Twitter
Yeah,
or
I
on
mean,
Instagram.
you see, and for other people, Google is basically the internet. You
Yeah,
give
sure.
them a domain name, and they
Yeah,
type it into Google.
yeah.
I've been there, done that, and it took me quite a while to figure out why they didn't end up on our website.
Yeah.
You know, like
And actually, it's wrong. Google isn't the internet. Facebook is the internet.
not for long. Facebook is telling people, hey, if you don't let us collect data for advertisement, we're gonna make it that you have to pay for it.
Whoa, whoa. Okay.
Don't think it's bad, to be honest.
Yeah.
It only tells you like, well, if you have to pay for Facebook, maybe it loses all the stupid accounts that are just trolling anyways.
Yeah. I think so. Well, actually,
But
to
that's a different topic. We
yeah,
should do a whole different session about that, I guess.
yeah, yeah, sure. But because actually, we wanted to talk about the internet for cows and chicken, and so I when I first heard about the idea of Cleverbit, this was when I remember correctly in Java land. Um, I wondered, why ever do you want to put a computer in a cowshed? This is so weird. So what was the idea
It's
of
simple.
this whole project from the start?
First of all, it's super simple. You need to make your customers happy.
Your customers.
Your customer. There you go. It took a second, but
Yeah.
exactly.
No,
Um,
it took 4 seconds.
no, so the idea is simple. There is a lot of laws these days in terms of the climate, the barren climate that animals have to live in, like ammonia levels, CO2 levels, stuff like that. But the problem is that because there's like no good technology today, what they end up doing is they fill out a piece of paper. So there's somebody walking into the barn in the morning, taking temperature, taking CO2 levels, writing it down. And there's somebody going in the evening. And everything in between is thin air, very thin air.
Yeah.
It's not exactly true because they all have like farm computers for their air conditioning and air filters and stuff. But it's not really that it is, well, collected in a way that it makes sense. Especially the biggest problem is your animals get ill for some reason, or they get sick, and your veterinarian comes in, and the only thing he can look at is this piece of paper with 2 numbers per day. And I was like completely helpless. So that was where we actually came in and said, okay, I mean, sensors and collecting data 24/7 is no black magic anymore.
Sure.
So why is nobody doing that? And there is a couple of competitors in the market, but they have most like these very old engineers. These engineers doing it for the last 30 years, and you tell them create a cloud platform, make something which is real time and analytical, and you can guess the result. I'm not bashing any competitors, but you can imagine what the result looks like, right?
Yeah.
So what we did is like, okay, we are talking to non-technical people. We're talking to farmers. We need something which is super simple and easy to understand. So what you get is we use an 868 megahertz frequency communication protocol, actually called LoRaWAN. So in case somebody is interested in that, pretty cool stuff. Low frequency, low throughput, wide range. We get about, you see everything depending on the building structure between 1 kilometer and 15 kilometers, which is pretty cool. We basically have like a LoRaWAN gateway, which takes the LoRaWAN signal and transforms it or bridges it to the internet with a SIM card. So that's your one power plug, and you have our device which you install in the barn, and that's your second power plug, and you're good to go. That's literally what it is.
Okay, so you actually are not recording in the farm. You're just streaming it live in the cloud. So everything what you do is in the cloud.
Right. Because so the device itself, and I unfortunately don't have one straight next to me. Let me see.
You don't have a cow at hand.
Yeah, I don't have a cow at hand. Give me just a second, but I have a device at hand. Well, actually, a dev kit device, so it's slightly different. But that's basically it. You get a nice coverage, and what you can see here is like these little ports. And you, what the main idea behind it is, it's a modular system. So one says I need ammonia and CO2 and temperature. The next one says I need a weight scale and stuff like that. And you can basically just plug and play the system you wanted. So that's the main idea behind it. And yes, we stream the data into the cloud. The device itself is powerful enough for future editions. We have a quad-core ARM CPU with a gigabyte of RAM and stuff like that. The ports support full USB 2.0. So in the future, we could go ahead and say, okay, we put a camera, a USB camera in the barn, and we do some image analytics on the device itself and just stream the result of that. So that is the main idea. Basically an edge computing use case, whereas all of the analytical engine basically is in the cloud.
Yeah. And I wonder what you're doing with updates. You said it's a modular thing. So if the farmer wants an update, he can plug in new sensors. And does he have to maintain the software part, or is this remote controlled over the cloud, or how does that work?
So the devices support online updating just the way we expected. So that's basically how you do it, right?
Uh-huh.
And there is a little part when you install a new sensor for the first time, it has to have internet connection because it kind of downloads like a little bit of a driver that understands how the module will send data over the port and transforms it into our standard protocol. Basically,
I
it's not
see.
really a driver in the driver sense; it's more like a bridge kind of thing. But
Yeah.
that's what you need. And the interesting thing that about that is this thing is written in TypeScript because it's basically just message handling. So you get in a byte buffer, you transform it a little bit, and you send it out.
I see.
TypeScript was like, it was easy enough to write. You have type safety, so you can describe the internal API. You get code completion, and you still have the option to just kill the Node.js or the JavaScript runtime. We're not using Node.js, but you can kill the JavaScript runtime and restart it when something misbehaves.
I see. I see. This is pretty interesting. Yeah.
Yeah, and the other way of getting an update is actually a module. So as I said, there's USB on the ports, and you get like a little bit of an extended USB stick, basically, that you can plug in that has the firmware on it and can update that way.
Yeah.
Because, well, we are in Germany. Not all listeners maybe, but you might not believe it, but Germany is a third world country when it comes to mobile networks.
Yeah, that's true.
That's unfortunately true.
Especially when you want to do a live stream in the evening.
Either that, or if you are actually talking about customers being in rural areas, guess what? Farmers are. Damn.
So what actually are you doing with this aspect? Because most farms are in the rural area. So do you have a special provider which does some kind of
Right.
satellite internet or something? Or how are you
No,
doing
so
that?
it's right. So that's one of the reasons why we use the LoRaWAN network. So the way it works is those devices actually only send out LoRaWAN. They have Wi-Fi connectivity for firmware updates and stuff, which basically means you open up a hotspot on your mobile phone or whatever. But because of the 860, 870 megahertz, it is very good in just ignoring any kind of walls. And what we have on the farm itself is the gateway, the LoRaWAN bridge, and that one has normal mobile network connectivity, normal mobile network, but it has a SIM card which can actually connect to any kind of network. So it doesn't matter which provider you have or which one is the strongest. It just connects to whatever is available.
I see. I see.
So
And
it's one of those IoT mobile providers, basically, that have agreements with almost all mobile providers in the world, I guess.
so actually, this should work everywhere, at least in Western Europe, because the mobile phone is ubiquitous, and so it will work even in the most forest or wherever your chicken will live. So
You would be
there are only
surprised.
few dark spots, I think.
Yeah, you would be surprised. I think it will be easier in any kind of country except Germany.
Okay. I don't doubt that.
Yeah, we actually have a couple of programmers in Vietnam, and they literally have mobile network in the deepest part of the jungle, which is insane when you think about that. You can actually drive in a city like Berlin or something in Germany, where you're like, okay, here's a blind spot. And like, what? How do you
Yeah.
manage to do that?
Yeah, because nobody wants to pay at that spot. So, yeah.
Maybe.
To get the big picture, what you're actually doing is you have a sensor, and the sensor gets plugged on this motherboard, and the motherboard pumps the sensor's information over LoRaWAN to the, let me say, to the curve where your bridge is installed. So
Right.
and from there you going by LTE or by UMTS or something like that, and from there you're in the cloud. Okay, I got that point.
Almost, yeah.
Yeah,
There's one
almost.
step in between because for LoRaWAN you actually need like a provider. that registers devices and stuff. So there's a little bit of device authorization going on. Right now we use the Things Network, which is a community-driven open source stuff. But we plan to basically set up our own
Okay.
for the future.
Okay. So yeah.
No, go ahead.
Yeah, when you're talking about we, I only know your face. So what is this we? Is there a big investor or who is that we?
We first and foremost is the four founders.
Okay.
That's me and three other guys. The story is actually a little bit funny because we first had the idea of the hardware and this modular idea. And our first idea was like, hey, that could actually solve all of the problems with smart home, where you basically have a new protocol every year and everything else dies. And you buy a hub for a lot of money and you can basically throw it away the year after. So that was where we all came from. It's two guys, it's Frederick and Dennis, and they have a hardware development company for, I don't know, I think more than 10 years now. So they do basically all of the hardware magic.
I see.
I'm getting better with that, but especially Frederick is still like way above me.
Okay, so they're original hardware engineers, because we know you from programming, from the software side. So you're doing all the analytic stuff, I think.
Almost all of the backend is up to me.
And yeah. And
no, go ahead.
Let me ask you one totally essential question in this context, because most people come here because they know us from Java, and you said you are using that other language. I wouldn't dare to tell the name. So is there at least something in that whole system where Java is used?
Yes.
Oh,
we have
great.
Hazelcast.
Yeah, great. Great. Good.
We actually use Hazelcast. No, so a language you don't want to mention is Golang. And let me quickly finish. So there's this fourth guy, which came up with the idea of this modular system. But actually, funnily enough, he has a farming background. So he grew up on a farm. He's taught farmer, and then he got into he moved to Shenzhen for a while and started selling chips.
Okay.
I don't know why you come up with that as a farmer, but it worked. And when we came back and we looked at the market for smart home, we figured, okay, that's not sustainable. You have a price fight, which we don't want to do. And then we thought about other things, and he came up with the idea of, hey, we could actually monitor farms or monitor barns. I was like, why would you monitor that? Like, for people that probably know a little bit of the like the farming sector, there's like this big German company for tractors, Class. Yeah. And those things are incredible. They basically drive themselves. We're talking about self-driving farms, self-driving cars. They have it for years. So I was like, what do you want to do? And I was really surprised when I figured out how low tech, let's be nice, low tech, the animal husbandry part of the whole farming sector is. So coming back to the other question, which I forgot now.
Where is Java involved in all that?
Right.
Because I have to stop the transmission when you say there is no Java in it.
No, right. So, right. The other language you don't want to mention was Golang or Go, which is, well, it comes from the fact that while we were prototyping and making sure that the idea actually works for people, the easiest way to get around was Golang. It was a couple of lines of code to do fully TSL, let's encrypt subdomains. You basically put the subdomain into the database. When some person tried to access it, you looked it up. Oh, I don't have a certificate yet. You call via Acme protocol to the let's encrypt server, and you just get a certificate and cache it. And I was like, I think it was like 20 lines of code. Try to do that in Java. Sorry.
Yeah.
I don't know of any framework that could do that in 20 lines. It's not about being Java, like this verbose language, with what people always say. It is just the Go runtime has all that in the standard library, and it's insane.
Yeah.
But it's only written for microservices, so don't try to do any bigger stuff with that. I actually have a pretty good talk about that.
Yeah, I know. That's why I wonder that you actually used Golang.
Well, the problem is Go is not a shitty language in itself. It has a couple of things where like, what the fuck was wrong with your brain when you thought that was a good idea? But apart from that, you can get extremely efficient doing it.
Yeah.
You can get extremely efficient just building that stuff. Then there is a little bit of Python code because analytical stuff, blah blah, right?
Yeah.
We all know machine learning is Python.
Yeah.
And what else? We have a little bit of Node.js, obviously, for some of the front-end services. The easiest way is just calling the internal services from Node.js because everything is CBOR or JSON, and you just pump it out again in an aggregated fashion. We have Hazelcast for a lot of caching to speed up object requests. So we have a very microservice-y infrastructure where you have a lot of internal services, one basically per resource type. And they call each other quite a bit. And that is where we added a lot of caching. And I'm not sure you know Zoran, maybe?
No, I actually don't know it.
Okay. So he's a good friend, and he's coming from machine learning image processing area basically right now. But he's looking into some of the stuff that we want to do, especially when it comes to like animal feed silos, to get some better data graphs. Right now we have the problem for silos. It's hard. We use a radar sensor, and as we know, radar can get some funny results sometimes. And we're currently working on an algorithm, a machine learning algorithm to kind of make it look nice, because we know what happens and when stuff is stupid. And I mean, you look at the graph as a human and you're like, that's not logical, that's stupid. But unfortunately, it's not that easy for computers. We know that.
That's the strange thing, that the things that are easy for humans are totally hard to do for computers. And
everything which is visual is hard for computers. Everything which is non-visual is hard for humans. That's
right. So
But to come back to your point, we will get some more Java. Well, actually, I'm sorry, we will get some more Kotlin. That's still
okay.
JVM.
That's like Dutch to German.
Exactly. Because as I said in the earlier, Go was, from my perspective, Go was created for microservices. We tried to do some more extensive, some bigger stuff with it in the backend, where we basically generate massive SQL queries to get as much analytical stuff into the database as possible. And this thing becomes a monster. And Java or Kotlin would make this much easier.
So you actually have a SQL database?
Yeah, we do. What we use is Timescale DB, which is a time series plugin for Postgres, and that's incredibly fast. So for anyone talking about you need influx or anything else, that's fucking bullshit. Sorry, but it's bullshit. It's just not true. So the guys built back their own storage engine, but you can still use all other plugins available for Postgres. You can use all the functionality in Postgres, and it's incredible. It's super fast and it works great for us.
So
And you get all the ecosystem of Postgres, which I think is massive,
yeah,
and
yeah,
it's
sure,
it's like Java.
yeah,
It's like Java for databases.
yeah. Yeah. Um, so to understand what you're actually doing is you try to improve the living situation for the animals. So when all this information is put into that timescale database, what is the benefit? What is the outcome? What can the farmer do with all that information then?
Right. So the easiest things, and that's what we're currently still implementing. I mean, we're still very early in the process. Um, the easiest thing is that you get 24/7, and that was our prototype. That was literally it, and people were blown. We showed them like a 24/7 graph of the temperature, and they've never seen anything like that. And that was kind of mind blowing for me, or mind boggling, because I was like, "What do you mean you've never seen anything like that? Every damn smart home system can do that."
Yeah, yeah.
So that's like the first thing. The second thing is alarms. We do some real time analytics, and we push alarms like, "Hey, this is your target line, and you are like 5 degrees above your target line."
I see. So
We
he
have
gets actively informed that it's
Yeah.
too warm for his chicken, for example, and he should improve the air condition or something. Ah, I see.
It's not only improving. Certain things like temperature and humidity can actually be deadly for chicken. So
Ah, I
the
see.
faster he reacts, the higher the chance that no animals are dying, which is important because when you try to optimize animal health or bring benefits to the animals, what you actually have to do, you have to bring benefit to the farmer, because why would he do that otherwise, right? So the
Because he
best
loves animals.
Right. That's what it is.
Yeah.
Pretty sure there are farmers, but unfortunately not all of them. But the thing that you can, or the part where you can come back to the farm and say, okay, we bring benefit to you, is cost cutting, and cost cutting means less dead animals, better growth rate, less feed, stuff like that. So those are like the things we try to push to the farmer, with this, like, by the way, if you get healthier animals and do a more like organic growth style, we can actually help you afterwards to sell that for a better price, which means you're not only getting the cost cutting factor, you can also earn more. That sounds like a good deal, right?
But
So
why can you sell it for a better price? I don't get that point.
so the idea is that, and that's like a little bit out in the future, but the idea is that because we have all those information, um, we can actually show customers, the end customer, hey, this is how this specific chicken was grown, and we can tell you, yes, it had organic feed, it didn't have any like bad climate against the law or stuff like that.
I
And
see.
for that reason, you can, like with any organic, you can charge a higher price. And a higher price, from my perspective at least, means we can give more to the farmer, and the more farmer has the intention to earn more, which means he wants to be organic, and that way we can probably not solve the problem, but maybe lessen
Yeah.
it somehow.
Yeah. I could
So that's
imagine
that's the
actually.
idea behind it.
I actually could imagine that there is a QR code printed on my milk, and I scan it with my smartphone, and I see all the graphs how good the life of this cow was when she was in that in a specific farm. So maybe
not
also
not not
this.
only for the farm, not only
Yeah.
for the farm, right? If you get like the whole chain, you can actually say, okay, how long was it transported between
Ah, I
the
see.
farm and the slaughtery? right? You can basically measure everything.
Yeah. So
There's a lot of stuff that we still need to collect for that, but there is a whole bunch of stuff that you can show the customer and tell them, hey, that animal, well, had a happy life.
until it ended.
Yeah.
Yeah.
Well, yeah,
True.
had a happy end. Wow.
That's the bad thing when you want to eat a cow, you have to kill it. Okay, so we
Right.
have to live with that. So
But
it's,
right, but I think we can at least try to make the rest of the life as good as
yeah,
possible. And for anyone who ever ate a better piece of beef, you definitely find a difference in taste.
sure.
So it's right. I mean, even as a customer, I have the motivation to buy the better stuff and say, hey, the taste is better, so why would
Yeah.
I get the cheap stuff? Unfortunately, in Germany, we have a different culture, but
Yeah, unfortunately, yes, that's true. Um, so your big picture is that you're currently at the start with Cleverbit, but you actually want to cover the whole topic. So Cleverbit will be the provider of the complete end-to-end chain, you could say.
at least we want to try to capture as much data. We don't
Uh-huh.
want to be the chain, but we want to capture data at any point in time in the chain.
Mm-hmm. And
Um,
yeah, and
that is a little bit easier for something like a slaughtered pig, because they be born somewhere, which is normally either a different barn at the same farmer, but most of the time it's even a different farm.
yeah.
So they being transported the first time, then they come to the farmer where they actually grow up or grow out. Then they being transported to the slaughterhouse.
Yeah.
So there's a couple of different things, and the longer animals live, the more transports are there,
So
and even that.
and you could imagine a mobile device in a transporter which collects data while the transport is going. So you could even track that the transport was fine for the animals.
For example, something like that.
Yeah.
It would be a little bit of a different technology, but yeah, you could basically do like a collar on a cow or something with the GPS tracker and some basic temperature or climate information.
Okay. And
That's, as I said, that's all like far future, but
yeah.
that is our vision,
So
what we want to do.
where in your business vision are you today? So is there something that a farmer can already make business with you, or is this completely in a
Yes.
beta level?
No, fortunately we managed to get out of a beta. It took a little bit longer than we wanted.
Uh-huh.
So that's just like our demo account for playing in engineering. As you can see, it actually has the dev domain.
Uh-huh.
And the overash farm is right here in my office. So none of the temperature curves or stuff will work, or will be correct, because it's very different. But what you can see is we can show you min max. That's probably, what is that? I think that is a manual hand input. So those are like the I think I opened the window at that point in time. You see, it works.
It works. Or the sensor is broken.
Or the sensor is broken. So you can actually change the resolution, like the aggregation resolution. What we do is we collect data at 1 minute granularity, which is way more than necessary. And in case we at some point figure out, okay, it's too much traffic or something, we could always go down to 5 minutes, and that will still be enough. But you can also see the target line, which is what farmers expect it to be at a certain point in the grow out round, in the fattening round. So they have specific values they try to meet, like temperature, humidity, stuff like that, right?
Oh, I never
The
heard the word. What's that?
enthalpy. Enthalpy is what is something specific to chicken or to any kind of bird. When we talk as humans, we talk about heat index, or the field temperature. the felt temperature, like how wind, humidity, and temperature work together to give what we think the temperature is, right? It can be 10 degrees and it feels like 16. So that would be like the heat index, basically. For any kind of birds, broilers, chicken, ducks, you use enthalpy, which is a combination of humidity, temperature, and air pressure.
I see.
Probably because they're closer to the ground. I have no idea why, but that is an index value. So everything above, I think 50, is like bad. Everything above 70 is like super bad.
Oh,
Something like that.
okay. So
Right.
super bad means that they will not survive it.
Yes. So enthalpy and heat index is a specific version of this like felt temperature for cattle. But in both cases, what it describes is the stress level.
Ah,
It's
I
not
see.
like for us where we say, okay, it feels hotter or it feels colder. But temperature or this enthalpy for chick means stress. And the higher the stress level, the worse. And a high stress level, a high enough stress level actually means they will die from stress. I'm pretty sure the Japanese have a word for that. Die by stress.
Yeah. Okay. So we can see here the different types of sensors that you can query, like ammonia, CO2, oxygen. That's light, I think, looks,
Yeah, that's the lighting factor
and
and
the
air
air
pressure.
pressure. I see.
Right.
Okay.
And you also, on the other side, as I said, these are all demo data, but we also collect all the information about losses. Um, we collect information about weight gain. I don't have a weight scale attached yet. Um, but on the other side, we also collect information from the veterinarians, like what medication was given. For chicken, obviously not, and like which chicken specifically got the medicine, because that's not how it works. But for pigs and cows, you would basically know exactly how much of what medication at what point in time for how long was given to any specific animal. And what we want to do with that, for example, is trying to correlate it. Maybe there's like some correlation that we figure out where we see, okay, some antibiotics is always given when humidity and I don't know, like what else? Humidity and ammonia, specifically ammonia, is above a certain level for a certain amount of time.
Okay, this correlation analysis is done automatically, or is that something that the farmer has to trigger? How is that working? Or is there artificial
It's
intelligence setting up all
right.
that?
It's not working right now.
I
We
see.
are working on the algorithms, but the idea is to use machine learning algorithms to figure out the. I always say the farmer's knowledge they don't know yet.
Yeah,
Um,
yeah.
so new correlations that farmers don't know today. There's a lot of stuff you can ask farmers, like those farmer rules for weather and stuff.
Yeah.
They know a lot because they figure it out over the centuries. But there's probably a lot they don't know yet. And ammonia is a very specific example, because we actually have ammonia rules, like in the law, how long an animal can be under a certain level of ammonia, but there's no real sensors to measure that, which
Oh,
is kind of a weird chicken and egg problem.
so how are you measuring it then automatically?
We actually have ammonia sensors, but
Oh,
you won't find any barn with ammonia sensors right now.
okay, okay,
You can probably count them on like one hand,
yeah.
because the problem with ammonia is, whereas temperature, humidity, all of that, those are like digital sensors. They don't expire. The problem for ammonia is that the measurement is done by a chemical reaction. So
Uh-huh.
that means that your sensor actually deteriorates over time. So you have to exchange it time over time, and it's a complicated thing. I guess we are working on a pretty good solution to extend the lifetime from like 6 months to probably like 3 years by now.
But
With
don't
a little
don't
bit
do
of
that. Don't do that. because
Yeah,
when you can have a subscription on ammonia sensors bundled with your offering.
yeah. The problem is a little bit different. The problem is a little bit different. That you actually have to recalculate them or recalibrate them time over time over time, and that's a nonsense job. So that's the problem with ammonia. That's why we try to get away from it.
Okay.
Then you have feed statistics. We don't have a silo attached right now, but it would automatically figure out how much feed is used and calculate that for chickens by the number of chickens in the barn right now. We have water meters, like water counter, that captures data. That's actually a funny one, because we capture the counter value, like the real counter, like what you also give you to your utilities company. And we had a little bit of an outage here. And that means this barn used 670 liters of water in like, what was it, like 4 hours or something.
Wow.
Yeah. So the number of water that actually goes into a barn is pretty insane. I looked at the numbers for the first time and I thought I had like a multiplication error. Like, no, that can't be right. I probably added a zero too much or something, but no, it's true.
Okay.
And as I said, we have the same thing for silos. That's a pretty boring silo right here, but you can actually see it's almost filled. This one, for some reason, doesn't seem to be used right now. Maybe there's no animals in the barn. That's one silo which is across the street from the office. The office itself is in a pretty rural area, which is cool. So we have a farmer that gives us the chance to do some live testing.
Cool.
But it would also show you like, okay, this is like your decrease in storage level. Here's a fill up event, and over time you can find patterns, and that would also be an interesting part where you could say, okay, if the pattern, if the baseline doesn't match what is going on right now, something is wrong. The animals are not eating. There's so many different things that you can do. It's the typical problem, like with any data or anything data. The options basically are limitless. You just have to find them.
And your beta farmers over the street, do you have a response from him? Could he already encounter the actual benefits of being part of the system?
Funnily enough, he doesn't use the system, at least not right now.
Okay.
We just asked him, can we install some stuff for testing? He was like, yeah, sure. He eventually will use it, and he likes the system, but he doesn't use it right now because the most of the system is very specific built for chickens right now, and he has a pig farm. So for that reason, we don't do that yet, but we will start implementing some specific things for pigs later, like to the end of the year somewhere.
So you can have a special option that he has to pay extra for pigs.
Something like that. Yeah. But from the other customers that we have, the responses are incredible. Everyone's like super happy. Obviously, it is a fast iterational process in how we develop. People have a lot of requests and a lot of features they wanted to see, and want to see. We are obviously not fast enough right now. That's why we were looking for additional money, and I finally will go full time somewhere in the near future.
Great.
Right now, I'm yeah. So right now, I'm still working for another company as well. In case people know, it's Instana, a great tool. It's basically. I always, when my colleagues in Instana ask me, what are you actually doing? I'm like, well, imagine it's Instana, but for barns, not for computer systems.
Yeah.
So for people that don't know Instana is an incredible observability tool.
Yeah, maybe it would be simpler to use Instana and update it to run on a barn. Then instead of writing everything from scratch.
I thought about this as probably like practical, but I think some of the algorithms at Instana are too specific to how the computer systems work. But apart from that, it's basically the same thing, right? You try to figure out the target lines, the baselines. You try to find anomalies, and you report on them. That's it.
Okay.
That's it.
And
Done. Two weeks.
next. Yeah.
Next.
And can you give us an impression? What was the top benefit that your beta farmers told you?
The top benefit, I think. So I'm not sure if I know like the top benefit, because I'm not talking too much to our customers, because I'm mostly
Maybe you should.
Yeah, but I'm mostly working on the implementation part, and as I said, I'm only doing like in my free time right now. So guess what? Time's limited.
Yeah.
But I think what I remember was like the response that was most shocking to this person when we added the first weight scale, like still a prototype, in a chicken barn. They expected like a very nice fluent growth in weight. What we actually measured was like, you have a growth, a little bit of stat, then it goes down a little bit, then it goes up again, and that repeats 3 or 4 times. I don't remember. And he was like, that's wrong. You guys are measuring wrong. My farm computer tells me it's a very nice line.
Yeah.
When we were like, no, I mean, that's what we measure. It's not like the weight scale will suddenly start measuring wrong and then it starts being correct again.
Yeah.
And we looked into that together with him and the veterinarian, and we found a couple of very interesting things. I think it was actually 2 times that they had like this weird curve. And what we figured, they change the feed 3 times. Like they have some starter feed, they have some grow out feed, or some fattening feed and some grow out feed.
Yeah.
And whenever they changed feed, that completely matched when the chickens seemed to lose weight for a day or 2.
They didn't like it.
Seemed like, well, it seems like that they need some time until they like super hungry again to switch feed. Like they just wait if they get what they used to.
That's interesting.
Right. And he was like completely blown when we found this like correlation. He was like, are you telling me that my computer, like my farm computer, that it's purposely built for that, was always wrong? We're like, no, but seems like we're not telling you, but that's what it looks like, right?
So
make your own guess from that.
Yeah. So maybe the very first benefit that farmer had was that when he's mixing both food for 1 or 2 days, maybe he can have a linear growth. So this is very interesting.
Maybe that would, yeah, that could be an interesting field test, for example, right?
Yeah.
That would be something where it's at like the farmer's knowledge that doesn't exist yet, because nobody was able to do that beforehand.
Yeah.
And if in the end the grow out round, the fattening round is 1 or 2 days shorter because of that, and they get like a complete additional one over the course of the year, that is certainly a cost efficiency factor that a farmer can't ignore, right? Sure. Yeah. So often it's like the little things, not even like, as computer engineers, we love to think big, right? Yeah. Like this massive machine learning algorithm, you just pump everything and data you have into it and you see what's coming out. But that was just a weight scale. It didn't do anything really. Yeah. It was just taking, we have a little bit of an algorithm because it's like a big plate and you don't know how many chickens are on that. So you have to guess based on the target line and previous measurements, will you think how many chickens or chicks are on the plate. And then you basically just divide it like, okay, so that should be the average weight right now for a chick. Yeah. But nobody did that before.
Yeah.
So it's really interesting, and that is, as I said, that's not even a big thing. The whole like algorithm is like 10 lines of code or something.
Yeah. So what we take from that is that farmers which are using your system will have healthier and more happy animals. If you can say animals are happy when they are on a farm, and
Well,
they
I
will
still
make
think
more
over the
money.
course of a lifetime they can.
Yeah, sure. And
I still want to believe that animals can be happy over the course of a lifetime. I mean,
yeah,
we are happy and we die eventually too.
yeah, sure. That's right. So that's a good closing word. So farmers should go with you to have more happy animals and to make more money at the same time. So this is a win-win situation. And is there a starting point when a farmer is watching this live stream, which I don't think. So where is the point where he has to go to?
Cleverbit.com. That's CLEVABIT.com.
Okay,
So
I
it's a
will
very
put it in the
special
video
way.
description so you can
Right.
press a link.
It's the cool way of spelling clever. It's the
Yeah,
clever way of spelling clever.
yeah.
Um, and just contact us.
Okay,
We are public, but there's like no online shop or anything because we still want to make sure that we know about the use cases, about the farmers. We're still pretty early, and we like to have like the direct contact to anyone. So
okay.
if anyone's uncle or father or whatever has a farm, let them know. We're happy to help out.
And we need to amend that you are also planning real farming, not just animals, but also actions on the field. I think, right?
Not right now.
Not right
But
now. Okay.
if somebody's interested, we certainly have partners that do that,
Okay.
and we're happy to forward.
Okay, great.
There's a couple of really amazing companies for that as well.
Cool. Okay, this was really interesting. Actually, I couldn't imagine anything about this eco informatics, or why a cow needs a computer. And I'm really impressed what you are doing and what the system is providing for the farmer and what the benefit for animals is. And I really wish you the best. And I hope that a lot of farmers will go with Cleverbit in future and improve life of the animals. So
That's
Christoph, sorry, thanks for being in the show and explaining the system to us. This was really great. We learned a lot.
Yeah. Thanks for having me. Was a lot of fun. It
Yeah,
was actually the first time publicly speaking about it, so that's great.
really. Okay, so I invite you when Corona is over. There will be an on-premise Java land again. So I would say bring a cow with you to Java land, and we will show Cleverbit in the community tent. Okay, guys.
I think the chicken use case would be easier.
Would be easier, yeah, okay, but not so funny.
That is true.
Yeah, okay, guys. Thanks for having us and good night. See you next time. Goodbye.
Cheers. Bye bye.
Ja, Prosit, letzter Schluck Milch.